Today we're going to do a lab in which we're going to try to find the index of refraction of a piece of glass. Now, the problem, of course, phrased in the form of a question is, what is the index of refraction of glass? There will be a number of materials which will become very clear to you as we go through the procedure, the description of what we're going to do today. In addition, there are three sets of variables. The manipulated variable, which there's one of, responding variable, there's one of those as well, and the control variables, well, there's almost an infinite number of those. I expect you, as always, to list only the really important ones. There's two really important ones here that you don't want to miss. Okay, beyond that, it's kind of gravy. These will become, at least the manipulated and responding variables, will become quite clear to you as we go through the procedure as well. You will have to think a little bit more about the control variables than you will those two variables. So how's this going to go? This is what your apparatus is going to essentially look like. You've got a block of glass here that's sitting on a piece of paper. That piece of paper is important because that's how we're going to mark the angles of incidence in the angle of refraction. Down in the bottom right-hand corner here, you see a laser. This is a relatively low-powered laser. It's called a class 2 laser, which means it's relatively safe. But I'll give you a little bit of safety spiel about that later on as we're finishing up this. We want to measure the angle of incidence as the light goes into it. We want to measure the angle of refraction as the light comes out into the glass. Here's how we're going to do it. The first thing is, when you put this block on your piece of paper, I want you to trace a line along the edge of the block. Okay, that's going to represent your boundary. Then you're going to turn on the laser. You, depending upon how you have your laser angled, you may or may not see laser on the piece of paper. You certainly won't see the laser moving through the air because it needs to reflect off of something in order to be seen. In any case, you will see a dot right here. You'll also see a dot where the laser beam strikes the glass. You'll also see a dot where the laser beam comes out of the glass. What I want you to do, after you've drawn that black line that represents the border between the air and the glass, is draw your dots. Draw these three dots, where the laser light leaves the laser, where it goes into the glass, and where it leaves the glass. Make sure you draw it as close as you can to the glass, and make your dot as small as you can so that it's still visible. All right? Then, I want you to do a little kindergarten work here and join the dots together. That represents the path of your laser beam. Now, finally, you're going to draw a normal line, which has to be drawn exactly at 90 degrees to that boundary. Now, I've got protractors. You're welcome to use a protractor, or you can just use the block itself because there's a nice 90-degree angle on that block to draw that 90-degree line there. Okay, whatever works for you, okay, draw your normal line. And then you've got to measure the value of theta 1. That's your angle of incidence, and your value of theta 2, that's your angle of refraction. Both of those need to be measured from the normal line, not from the boundary, but from the normal line. Then you got to record them. Theta 1 goes right here, and theta 2 goes right here in the second column. Repeat that at least 10 times. Let's say minimum 10 trials, maximum 1,000 trials. You're probably going to lean more towards the 10 than the 1,000. There's a couple more things you need to write down here. Medium number 1, that's going to be air. Medium number 2, that's going to be glass. And the index of refraction of air as found on our data sheet would simply be 1.00. We don't know the index of refraction of the glass. That's what we're trying to find, so we're certainly not going to record a value for that. Once you have that data table of theta 1 and theta 2, you're going to convert that to an analysis table. Now listen carefully. This is one of the mistakes that some of you guys made on your last lab. Data and analysis are separate. This is what we record today in this room. This is data. We haven't done anything with it yet. We haven't done a calculation. We haven't plotted a graph. We haven't done anything with it. As soon as you do a calculation, as simple as that calculation may be, like for instance in your last lab, multiplying mass by 9.81, as soon as you do that, it becomes analysis, a separate category. Now, this analysis is not going to involve gravity. This analysis is going to involve a little bit of trigonometry. We're going to take the value of theta 1 and theta 2, and take the sine of each of those angles. Sine of 30 degrees, sine of 40 degrees, whatever your angles were, and fill those values in to this table. And then you're going to plot a graph that is going to be sine theta 2 y-axis versus sine theta 1 x-axis. Always y-axis versus x-axis. By the way, another mistake that some of you guys made in your last lab is the title. The title is always y as a function of x, or y versus x. In this case, it would be sine theta 2 versus sine theta 1, not the reverse, not sine theta 1 versus sine theta 2. This graph, when you go to plot it, will be a straight line. And it should theoretically go through the origin. How do we analyze it? Same way as we always do. Y equals mx plus b because it's a straight line. The y-axis is sine theta 2. M is the slope. X is sine theta 1. And b, the y-intercept, will either be 0, it should theoretically be 0, or it'll be really close to 0 so that we can ignore its value. Then you get an equation from your data sheet that has the same variables in there. Which equation on your data sheet has sine theta 1 and sine theta 2 in it? Snell's law, good. So we're going to say sine theta 1 over sine theta 2. Now there's 4 parts to Snell's law, right? There's one of them. What's the other part that you think we're going to use for this one? Yeah. Yeah, n2 over n1. Since we're trying to find an index of refraction, it stands to reason that we're going to introduce that somewhere in my equation, right? Now let's rearrange this. Take the same form. Sine theta 2 has to go to the top by multiplying. n1 goes up to the top by multiplying, and n2 goes down by dividing. Lots of things going on there, but what we end up with there is this. Sine theta 2 equals n1 goes up, n2 goes down, times sine theta 1. And then we cross off things that appear in both. The slope of this graph ends up being equal to n1 over n2. We have the slope given to us by Google Sheets. n1 is 1.00 because that's the index of refraction of air, and we're solving for n2, the index of refraction of the glass. Now, what should we get for the index of refraction of glass? No, you're thinking of water there. Yeah, it's somewhere in the range of about 1.5. Okay. Don't panic if it's not perfect, but you will almost certainly get a good number, a good result for this. May not be exactly 1.5, but you'll get in the range, certainly. All right, we've calculated that value of N2. That's what we're looking for. My conclusion is simply, what's the value of N2? The index of refraction of glass is blank. I know this because they would provide a brief explanation as to what you did. Sources of error, remember you want to list 2 or 3 good sources of error, and then suggestions for improvement. Somebody asked me a question this morning ahead of time before he actually completed the lab. He said, would this be a good source of error? I'm not going to tell you what it was. And I said, well, yes, but you've noticed that before you completed the lab, right? He's like, oh, well, I said, you can still fix it. In fact, I'd rather you fix it before you do the lab than after, right? And you can still use that as source of error. Okay, you're not ruining your source of error by fixing it ahead of time. I would rather see you say, oh, this was a potential source of error that I recognized and I fixed it by doing this, as opposed to, oh, I figured this out after the fact and this is what I do next time. So if you catch it ahead of time, fix it. You can still use that. Just tell me how you fixed it rather than how you would fix it. Okay, fixing it ahead of time is way better than fixing it after the fact. Finally, there is a little bit of a safety note here for you since you're using a laser. I said it was a class 2 laser. The power of this class 2 laser is about 1 milliwatt. Okay, generally, that's considered to be very safe. Having said that, you don't want to shine this in anybody's eyes for obvious reason. The blink reflex would almost certainly cause you to blink if it accidentally went into somebody's eyes. But even then, we want to avoid any possibility of that. So here's what I want you to do. First of all, the laser light can only be at desk level or lower. So do not turn the laser on when it's in your hand up here. Okay, turn the laser on only when it's on the desk, period. If you happen to be just testing it to see if it's working or not, point it at the floor, point it downwards at the floor. Got it? So either at the floor or on the desk pointing horizontally. That should avoid anybody from accidentally getting laser light in their eye. The other thing is, if you don't have the laser in your hand, you're just doing something in the room, make sure that you're not down at desk level trying to find a point, a data point like this. Make sure that your head is at normal height so that you, again, don't accidentally get exposed to this laser light. Even if you did, by accident, you will almost certainly not damage your eyes. But if you follow those safety precautions, you will for sure not damage your eyes. Okay? What do you got to add in for this? Your problem and your materials, your variables, manipulated responding and control variables, your data, which of course consists of one table, your analysis, which consists of another table and a graph, your conclusion, and your sources of error. Due on Friday.